Okay, so this is the question 7.1. It looks very complicated, but it's just you just need to subtract and divide something, and it's pretty easy. So please give it a read, and if you want, you can stop the video, and then we can answer it together. So let's start breaking the question in several parts to try to understand it. So first thing that they said is that we are going to have a bacterial culture, and this bacterial culture will have different genotypes. Here are the genotypes, and I want that you observe the different genotypes. What are the similarities and what are the differences? So the similarities are here. All of them will have a streptomycin. Yeah, the streptomycin gene, I mean. So all of them will be resistant to streptomycin. Yeah, they will survive if the media has this antibiotic that will kill all the bacteria. And on the other hand, the difference are here, the first two that you will see here. Some of them will have, and some of them will don't have methionine. So, for example, this one don't have methionine, and this one will have methionine, and this one will miss leucine, and these two will have leucine. Okay, so we have a bacterial culture that have different genotypes, and now what we're going to do is dilute those samples, making aliquots, and you're going to grow those in a media, plate them, and then so we're going to do this section. Take your pipette, then plate them, and then what you're going to do is to use different media. Yeah, so one media will have a media that have everything. So everything will grow here. Has methionine, leucine, streptomycin. You will have one that have everything except leucine. One have everything except methionine, and this one will miss both leucine and methionine. And so this one will grow everything, and this one will grow much less thing, will grow only things that already have leucine and methionine. So this can be our control for everything, yeah? So let me show you in the following slide what you have to do. So here you have the result table. And as I said before, you have 1, 2, 3, and 4 media. Here is the one that have everything. So you have the 400. So, and here you have the one that meet the methionine of the leucine. Yeah, so one will be, this will help you to calibrate your data. So here is the one that already have the data, even the bacteria with the methionine and leucine, even before in the aliquot, and this is the one that have everything. Okay, so this will be key to help you to calculate the other ones. And here, this one, it will be fundamental for you to calculate the one that missed this and the one that missed this. Okay, so here they ask you, based on the data on this table, what are the estimated percentage of genotypes of the yellow one, the blue one, and the gray one. Yeah, and remember this one, it will help you to calibrate to the real concentration of that, because remember this one, it didn't have anything and it still show growth. So let's try to go and solve it. So to understand this question, the first thing that we need to understand is that each media will allow to grow different cells. So for example, here in this one, all the cells are going to grow. The cells that don't have the methionine gene, the genes that don't have the leucine gene, and the ones that they also have it. Yeah. Here, try to guess which one. This one don't have leucine, so which cells are going to grow there? Yeah, in this second one. Okay, so here definitely the leucine and the methionine are going to grow, but this and the one that don't have methionine, but the one that don't have leucine are not able to grow. Okay, and here try to guess which one will grow here. Yeah, of course, the one that have leucine, methionine are going to grow, and the one that don't have the leucine are going to grow. The ones that don't have the methionine are not going to grow. And finally, try to guess which one are going to grow here. Yeah, so only this one, the one that have these two genes, the one that miss, that don't have the methionine and the leucine are not going to grow. So the key of this question, what they are asking you here is, what is the percentage of that you have a genotype that of the bacteria don't have the leucine? So how you obtain this, the percentage of this? You have to remove these two, that the colonies that you know that they grow in this media. Yeah, so how do you do it? By subtracting the number of colonies here. So, and the same thing will happen here. If you need to look only for the colonies that only grow methionine, you have to subtract this one. Yeah, and how you do it? You have this. In addition to that, the other component that they are asking you is a percentage. And how do you find percentage? So to find a percentage is very easy. Yeah, so you have a part versus a whole. And what will be the whole? The whole will be the one that grow all the bacteria. So in other words, this always is going to be the whole, 400. So you will see all of them divided by 400, and the part will be or only this one, or only this one, or only this one. Yeah. So now that question that looks so complicated is much easier. And here are the answers. Yeah. So for example, for the ones that have both methionine and leucine, it will be the whole that is 400. Yeah, and the part that it was 160, the one that missed the two of them, so it will be 40%. For the one that missed the methionine, it will be again the whole 400, and you have to remove the extra ones, the one that are the minimal, and this is for the reason it will be 140 divided by 400, that it will be 35%. And finally, the one that don't have leucine, it will be only at 25%. Again, all of them, the whole will be 400, and here it will be the quantity of only those colonies. Okay, so this was the explanation of how to do this one. In the following part of the video, I'm going to show in a much slower, I'm going to explain this in more detail, and so if you have a doubt, you can stay here. So again, we have this table, and they ask this question. Yeah, 106. What is the probability of getting these two, the colonies that have these two genes? So we know that it's 40%. How do we get it? Because we have the total here. Yeah, the one that have all of them, and so this will allow all the cells to grow, and the one that allow don't allow any cell to grow that don't have those genes. Yeah, so the one that have methionine and leucine before already in the aliquot, it will be already there. In other words, with the schematic, what you have to do is how to calculate that percentage is the parts divided by the whole multiplied by the 100. So the whole, it will be you're growing all these cells, and the part it will be, but you're only interested in these ones. Yeah, so pretty easy. You just divide this 160 divided in the whole, that is 400, and you get the 40%. So this was the easiest one. You didn't have to subtract anything. You just have to have divide the part divided by the whole, as is shown here. Okay, let's go with another questions with the following genotype. So now we have to find the percentage of the genotype that miss the methionine. Yeah. So how we do that? So we take the table and we know that this one that have the additional methionine will allow to grow the one that lack methionine plus this one that we find here, the one that have both genes. So to find the correct percentage, we need to remove these ones. Yeah, we need to grow to find the percentage only of the blue ones. So how we do that? By just subtracting 300 minus 160. And when you do that, you get 140. Okay, so this is where this 140 come from. And the next step is just to find the percentage. So let's do it with the schematics. So again, here you find, and we don't need to have these ones, yeah, these two genes. So how we do it? By subtraction. And so we take, as we said before, the 300 and we subtracted 160, and this is how we get 140. And the next step is to have the percentage. And to get the percentage is very easy. It's again the whole, that it will be this one, the 400, yeah, and the parts will be only this one, yeah, so it will be 140, that is the part, and divided by the whole, and multiplied by 100, and this will give us 35%. Okay, so now let's go for the next genotype. In this genotype, they are asking us for the one that miss the leucine. So here, the one that have this leucine plus will allow this that genotype to grow. However, again, we are not only going to grow this one, but we are also going to grow the one that have the 2 plus. So how do remove those ones? By subtracting, so we don't need this one, and we subtract that one, so it will be 260 minus 160. Yeah, and this is how we get 100 here. And then we just have to find the percentage, the part divided by the whole, and this is how we get 25. Okay, so now let's try to do it while using schematics again. So in this plate, again, we will have not only the leucine negative, but we will also have these ones that we don't need, yeah, that it will give us the wrong amount of colonies. So how we remove them? By subtracting. So it will be 260 that you can see here minus 160, and in this way you get 100. Now the next step, as I said, is to find the percentage. Okay, so now percentage exactly the same. We just have to take this one, that is 400. I know that you already know, and the next one will be here, the one that is only 100, yeah, this only. So we divide 100 divided by 400 and we get 25%. Okay, so now uh, we know all the genotypes, and we know that it's not complicated. The most complicated was to understand that you need to have different media, and that different media will grow different uh, type of bacteria, and if you understand the logic, you can calculate very easy the genotypes. Okay, if you have any doubt, let me know, and have a good day. Bye.